Hello students. We can start with fibers and forensic science. So fibers are one of the most important trace evidence that you obtain from a crime scene. So fibers, especially in terms of Locard's exchange principle, if you're talking, means it is a trace evidence, a very small evidence where a person when they commit a crime. So the suspect or the victim, they might have the exchange of fibers in between the person, or the suspect might have left a few strands of fibers from the dress at the crime scene or on the victim, or the victim might have lost certain few strands of fibers in the crime scene. So for linking between the suspect and victim, or for linking between the suspect to the crime scene or victim to the crime scene and all, fibers are a very good trace evidence. And if you tell about fibers, there are different type of fibers. Mainly you have natural fibers, that is plant fibers are there, which has cotton, linen or flax, jute, hemp, all of these things are there. Then you have animal fibers like wool, silk and all. Then you have man-made or chemical fibers, where you have the regenerated fibers, which is made mainly from cellulose, for example rayon and viscose. And then you have the synthetic fibers like nylon, polyester, acrylic and all is there. So when examiners are looking at it, first they will do the physical or morphological testing. So they will look at the shape, the color, the texture, the surface of the particular fiber through the help of stereo microscope or through polarized light microscope. They will be able to analyze or examine the fiber in detail. The next important thing that they will do is to understand about the synthetic characteristic of the fiber in detail. They will do certain optical properties in the fiber. So that is refractive indices, birefringence is there, sign of elongation. So people then generally get confused between these terms. What is refractive index? Refractive index is nothing but speed of light in vacuum to the speed of light in fiber basically. So that the ratio between speed of light in vacuum to the speed of light in fiber, that basic ratio is called as refractive index. So it helps us to identify any kind of unknown fibers and all. Refractive index is used. Birefringence, from the name itself, you can understand bi means two. Birefringence means the ratio between the two refractive indices of a same fiber. I'm taking a same fiber and I'm taking two different refractive indices, and I'm basically putting a ratio between the two refractive indices of the same fiber, means that is called as birefringence. Okay, so mainly especially fibers which are having a similar appearance and all, to differentiate and study them in detail, birefringence is a very good characteristic feature, very good optical property. Now coming to sign of elongation, means here it what to say it shows whether the refractive index is along the fiber which is greater or it is lesser. That is, you are taking a longitudinal section as well as a transverse section of the fiber, and you will be basically able to compare and see whether the longitudinal refractive index is greater or the transverse refractive index is greater. For example, if you are taking the longitudinal refractive index is greater, means that is of the positive sign of elongation. If the transverse refractive index is greater, means that is of the negative sign of elongation. And then you have interference of color. Basically, how the colors are able to interfere under polarized light can be seen. So these are all the important properties. And chemical properties also. For example, how does different fibers react when you're burning, when you're melting, when you're adding to organic solvent? How do they react? For example, cotton. If you burn it, all of the plant fibers, they burn very quickly. And cotton, especially when they burn, they have a ribbon-like appearance. Okay. So how do they react with specific solvents? What is their burning behavior? What is their melting behavior? All are the chemical properties of the fibers. And then comes your color analysis. So you have microspectrophotometry. There are different instrumental techniques that you can determine, that can be used to compare the dye patterns and shades of the fibers and all. And to understand about color, we use microspectrophotometry. To understand about the polymer type, for that we use FTIR, that is Fourier transform infrared spectroscopy to use it. We use that to identify the polymer type. So main forensic importance I told you for Locard's exchange principle, and you get the question fibers and you get the known fibers and you do the comparison and see, you do the optical properties, chemical behavior with organic solvents, you just check about the burning behavior, melting behavior, all of those things. So you will compare and analyze the color, the shape, the surface, the chemical properties, optical properties, everything, and that will help us to analyze whether the fibers are from a common source or they are from different sources. Clear? And after you obtain the fiber from the crime scene, obviously similar to hair only, we obtain using a forceps, and then we document it basically. We photograph it, we make notes out of it, and we also take reference fibers again, and especially in testimonies and court testimonies to support our court testimony. For fibers are a very good trace evidence, a supportive evidence as well. So there are certain PYQs that I've taken here. We've discussed certain PYQs related to this particular topics as well. So which of the following is a specific test used to confirm the presence of hemoglobin or blood stain by forming characteristic pink microcrystal? When you see pink microcrystal itself, it's basically Takayama crystal test. So here it's a microcrystal, a clue is there. So Takayama crystal test is a basically confirmatory test used to see whether the particular blood stain is of blood or not. Okay. And now the next is. Sorry about that. In death due to drowning and all, dye atoms. Again, about dye atoms, you will study about them in detail when we are covering forensic botany. So, dye atoms are nothing but certain specimens, basically like yellow algae. So, they are found in almost all of the water bodies and they are very, very resistant. They can thrive in any kind of environment and all. So, diatoms are found in which of the following, especially in drowning cases and all, accidental drowning or suicidal drowning cases and all. The diatoms go and accumulate in the femur. We know femur, right? Thigh bone. That is the longest bone of a body. There it goes and accumulate, and then it gets delivered to the bone marrow, bloodstream, and all. It entirely goes and delivers there. And next is in forensic serology, absorption elution is a method. So there again, this is a particular method to determine ABO blood grouping. So ABO blood grouping was introduced by Carl Landstein. From the dried blood stain, also you can discover the blood grouping of the particular individual can be done with the help of a technique called as absorption elution assay. Okay, so the option is 2 is the right answer. And the next is which of the following produces antibodies directly? Means B lymphocytes are mainly helpful in producing antibodies directly. And the next question is seminal fluid stain is identified presumptively by what? We already covered this. Seminal fluid has something called as acid phosphatase, which is an enzyme that is naturally present here. So when we do acid phosphatase test, it is a presumptive test to identify the presence of seminal fluid or presence of sperm. So acid phosphatase test is the right answer. And the last is which of the following is correct about saliva? So saliva as basically salivary amylase, alpha amylase and lysozyme is there. This lysozyme has basically antibacterial properties and all. It is also present in your eye tears as well. Okay, so any kind of microorganism which tries to enter into your body through food and all, no? So lysozyme basically fights against it. So that's it, guys. Thank you so much.